So today we'll be discussing few good problems from arithmetic geometric progression, because in the first session on the theoretical portion proofs were discussed, and this proof is also very important to learn, because we're learning for olympiads is we do not know what kind of questions they are going to formulate, so proving part is also very necessary. So today we'll directly start with questions. The first question is available on the screen. Find the value of a2, a4, a6, a8, so on. A1, A2, A3 is an arithmetic progression with common difference 1. Okay, so just try out the question. If you've already solved it, no need to wait for me. But there is a special technique for solving this problem. There are a lot of technique even for any mathematical problem. There are 2 to 3 different kind of method that can be used to solve these problems, and we can't generalize that this is the only method to solve the problem. No, it's never like that. One method can be easier, one method can be complex, one method can be lengthier. That's it. So the first method, let's see the first method. This is a normal method. This is a AP with common difference 1. With common difference 1. This is the first term, and number of terms are 98. So we can apply the formula n by 2 into 2a1 plus n minus 1, that is 98 minus 1, 97 into d, which is 1, equals to 137, and we can find out the value of a1. Now if we can find out the value of a1 from this, we will get a1 solving this equation. Now if we can find out the value of a1, we can easily find out the value of a2. A2 will be a1 plus 1, right? Just look at this step. Okay. Before that, let me discuss a very important thing. Just this format gives me the idea. That is recursive form of AP. What is recursion? A lot of us knows what is recursion, and first important thing that recursion reminds me of, that recursion is out of syllabus. Now who is defining the syllabus for PRMO? No, I'm no one to define the syllabus for PRMO, but I'm just saying that based on the past 10 years paper analysis, we can say that recursion is a out of topic syllabus. But no one can define its syllabus. Yeah, that's true. No one can define its syllabus. That's true. But based on the past 10 years analysis, we can say that this is a out of topic thing. Now, those who are learning these things, they can learn for definitely for the love of mathematics. They can learn anything. But since this, we have named it what? PRMO bootcamp. We have named it very simple. PRMO. Bootcamp, right? So this is a exam specific bootcamp. This is not a discrete mathematics camp or like that. So we will be syllabus specific, and syllabus is based on past 10 years analysis. So what is the recursive form? I'm just telling you that an, this is n plus 1 equals to an plus d whenever you will see this form, right? Whenever you will see this form, this is defining a AP. This is defining a AP. How? Just look at this, compare this, compare this. If you are understanding this statement, this a2 can be written as a1 plus 1, then why you can't understand an plus 1 can be written as an plus d? Here d is what? Here d is 1. Here d is 1. Similarly, a gp can be represented in such kind of formats. How can we write a gp? An plus 1 over an equals to r to the power n. So an plus 1 can be written as r to the power n into an. Am I right? Will it be r to the power n or simply r? This will be simply r. So this is the recursive form of a GP. You can write it as a note. So these are very common thing. So A2 can be written as A1 plus 1. The calculation is your task. From here you can calculate the value of A1. With this value of A1 you can calculate this A2. Now if you can calculate this A2, this is the first term of this sequence. The number of terms are what? 98 by 2 in this sequence, right? 98 by 2, that is 49. And the common difference is 2. You can easily find out the value of the sum. But this would make the entire calculation, a bit lengthier one. So let's go for an easy solution. Just now we have seen a very interesting thing. That an plus 1 can be written as an plus d. So here d is what? Here d is 1. D is the common difference. So a2 can be written as a1 plus 1, or a1 can be written as a2 minus 1, right? Similarly, a3 can be written as a4 minus 1, a5 can be written as a6 minus 1, and so on. So on. Just put these values of a1, a3, a5 in this equation. What will happen? Just look here carefully. Just look here carefully. A1 can be written as a2 minus 1 plus a2. A3 can be written as a4 minus 1 plus a4. So on. We have 98. Before 98, what we have? We have 97, and 97. Here we have 97. Here we have 97. This 97 can be written as what? A 98 minus 1. This is 98 minus 1 plus this A 98 equals to 137. Now what we're getting? Just look at this carefully again. This A2 is 2 times, A4 2 times, 98 90 is 2 times. And this is the required sum, right? This is the required sum multiplied by 2, because everything we are getting here 2 times. And what about the minus 1? How many minus 1 we are getting? Remember that all the odd terms, A1, A3, A5 have been converted. A1, A3, A5 have been converted into this format. So how many odd terms are there? If the total number of terms are 98, then odd terms are 98 by 2, 49. So 49 minus 1 you are getting here. 49 minus 1 you are getting here. So how how much it will be? 49 into minus 1, this will be minus 49. This will be minus 49. So you will get what? 2 times of A2, A4, A6, so on A98 plus A98 minus 49 equals to 137. Just transpose it here and divide it by 2. Transpose it here and divide it by 2. What you will get? 137 plus 49. 137 plus 49 divided by 2. This will give you the value of this expression. So this was a shortcut method. There are a lot of different methods. So we have shown 2 different methods. You can find out your innovative method that will be more interesting for you. So question number 2. Now it would be easily visible. How many distinct non-similar triangles have angles whose degree measures are distinct positive integers in arithmetic progression? Pretty easy, right? Non-similar. Say this is the triangle ABC. Angle A, angle B, angle C are in AP. And sum of angle, this is very basic geometry, is what? 180 degrees. Angle B equals to 60 degree. Now the number of different values of angle B you can have. The number of different values of angle B you can have will give you the number of triangles. What? No, this is totally wrong. This is totally wrong. What am I doing? Just a minute. Say angle ABC are in AP. Say angle ABC are in AP. Let me denote this by A, this by A plus D, and this by A plus 2D. A plus D, A plus 2D. Add them up. A plus D, A plus 2D, 180. You will get A plus D equals to 60 degrees, right? Which is the midterm itself. Now, the different pairs of solution of this A plus D, different pairs of solution of this A plus D will give us the number of triangle. Now let me focus on the question. How many non-similar triangle have angles whose degree measures are distinct positive integers? Distinct. So if D equals to 0, what will happen? If the common difference is 0, then all the angles are in AP, means angle A equals to angle B equals to angle C equals to 60 degrees. That the triangle will be an equilateral triangle. But here the given condition that the angles must be distinct. So D can't be equals to 0. D is greater than 0. D is greater than 0. Here I will use Beger's method, though this can be solved quite simply using logical reasoning, but I'll use Beger's method for restrictions that have already been discussed in combinatorics. In such kind of situation, assume D dash plus 1. Why? because the minimum value of d is what? Greater than 0. That is, the minimum value of d is greater than equals to 1. That's why there is 1. And this is d dash. So the range of d dash starts from 0. Now, since the range of d dash starts from 0, we can apply Beggar's method or stars and bars method. The name is different, the thing is same. A plus d dash equals to 59. Using Beggar's method, the number of solutions will be 59. This is 2. There are two distributions, plus 2 minus 1. Choose 2 minus 1. This will be 60. Choose 1. That is, answer is 60. 60, choose 1. Answer is 60. So, combinatorics. Here, I've given you a glimpse of my favorite topic, combinatorics. 2 questions. Okay. So, definitely in today's session, we have picked out very beautiful questions from the world over. The first few questions belong to America, and you can see from the fourth question onwards, we have picked two questions from China, and then at the end we will pick questions from India. Now it's visible. The sum of the first 2011 terms of a geometric sequence is 200. The sum of the first 4022 term is 380. Find the sum of the first 6033 terms. Pretty fine. So, what is the formula for GP? Let's have a recapitalization. This is the formula for GP when R is greater than 1. When R is less than 1, formula of GP is written in that format. And when n tends to infinity, this term will be infinitely small. This R to the power n will be infinitely small since R is less than 1 in this case, right? R less than 1 and n tends to infinity. So this will be infinitely small. R to the power n tends to 0. So we will have A into 1 minus R as sum of infinite GP. And the only condition is that mod R less than 1. There will be mod, right? There will be mod. So this was the small recapitulation required to solve the problem. Though for this problem also, two different methods will be shown. One is the normal method that most of you will solve, and one is a good method. The sum of the first 2011 terms of geometric sequence is 200. The sum of the first 4022 terms is 380. Find the total. Find the sum of the first 6033 terms. Okay, fine. Pretty easy question. So let me write this normal equation. R to the power 2011 minus 1 R minus 1 equals 200 A into r to the power now you can simply, I'm just giving you the method, simply divide this equation by this equation. So when you will divide, you will get an equation in terms of only these two expression. From here you can find out the value of r to the power 2011. Just take r to the power 2011 as some a is already there, we can't take, say it is x, take r to the power 2011 x, this will be x square, this will be x square, and you can simply solve it out. Now there's a contradiction, that if you solve it using this method, how can you find out the value of this a into r to the power 6033? Okay, fine. Say this is equals to some k. Now you know the value of x, so you know this value because this is nothing else but x cube. Divide this equation by this equation and find out the value of x. Find out the value of x. Again and again I am repeating the process. Divide this equation by this equation, find out the value of x. I am not going to solve. Put this x in this equation and again divide them. Again divide them. So this value, just look at this. You know the value of r because you have already solved from these two equations. You know this part, right? You know this part. I'm just repeating what you know. You know r to the power 2011 minus 1 because you know the value of r to the power 2011. So you know the value of this part. You can find out the value of this part. You need to find out the value of k here, right? Now the step is very simple. Again, divide the first equation. Divide the first equation. This one, right? The first equation by this equation. Now what are the terms that will be cancelled? This a will be cancelled, this a will be cancelled, this r minus 1, this r minus 1. And what will remain? This r to the power. Oh, it's extremely invisible, right? Let me write it from the beginning for proper visualization. I will just give you the method. I will not solve it using this long method. I'll just give you the trivial long method. This is the first equation. This is some k. We need to find out the value of k. These are the three equations. I'm giving the step. First step is that. First step, divide equation 1 by equation 2 and consider, let r to the power 2011 equals to x. Solve for x, you will get the value of x, right? You will get the value of x. So if you get the value of x, what are the values you are having? Now the value of x is known for us. This r to the power 2011 minus 1. You know this value, r to the power 2011, this part. You can find out this value. Now divide equation 1 by equation 3. Divide equation 1 by equation 3. So this part, they are the known values, they will be cancelled and you will get a ratio proportion sum. You can easily find out the value of k. But again, this entire method is a lengthier one because this is the trivial method. Let us go for the short method. Say, I'm giving an example that will be pretty much easier for you to understand. Say 6 terms are in GP. Let me write out the 6 term. Okay, I'll tell you later on. These are 6 terms in GP. What can you comment about the sum? Sum of the first two terms. This, say this and this. Look at this step very carefully. Sum of two terms taken at a time, right? This will be r square, this will be a r to the power 4. So these are the sum of first 3 terms. Now can we see something? Let me consider this as a, or this as this capital A. This will be AR, this term, and this will be a r square. So the sum of the terms are also in AP. Amazing, right? This we are going to use, which will make the entire question extremely easy. The sum of the first 2011 term is given. The sum of the first 2011 term is given 2011, 200, right? 200. The sum of the next 2011 term, that is 4022 terms, are given. Just subtract the sum of the first 2011 terms from here. You'll get the sum of the next 2011 terms. So sum of next 2000, this is first 2011 term, second 2011 terms. 10 is extra. Yeah. Will be 380. $180. One thing you can see that the common ratio of this GP is what? Decreasing, because the sum of the second 2011 terms are decreasing. So what we have solved in the first equation, the first method, there we considered r into n minus 1 a multiplied by r minus 1, this formula. So this was not applicable. Though if you solve this, when we are solving this for finite values, here n is finite, right? No matter how you write, you can write in this form. When n is finite, n is finite, this is 1, okay? Both the format are valid when n is finite. That doesn't matters. where does R belong to? The range of R doesn't matter. But though conventionally we use this because when R is infinite, we should use this format in case of mod R less than 1, or else the sum will be infinite only, or else the sum will also be infinite. Okay, so that was a mistake. So the answer that you will get using that method will be absolutely correct, because as I said, for finite number that doesn't matter. So second 2011 term sum is 180. So what the ratio of decrease is what? 180 by 200, 9 by 10. So the next 2011 terms will be what? There is a third 2011 term, 9 by 10 into 180, right? This will be 9 into 18, 9 9 81, 162, right? So this is the sum of first 2011 term, this is sum of next 2011 term, this is the sum of next 2011 term. To get the value of sum of the 6033 terms, right, simply add them up, you will get it. So this was the incredible solution of this problem. We need to hurry up, we can't give such kind of long explanation for these easy problems, consuming time for 15 minutes in a problem. Now again, a good question, definitely it's a good question. Maximum ratio. Just you can see one thing, that sum of first 15 term is positive, and the next term becomes, when added the a16th term, this makes the entire 15 term resulting to be negative. That means the common ratio is less than 0, not the common ratio, common difference is less than 0, common difference is negative. So this is a decreasing AP. First information that I can make it is a decreasing AP. So decreasing AP means what? So look at this very carefully. A1 greater than A2 greater than A3 greater than A4, so on. There is the terms are decreasing, but the sum will be what? Well, it's decreasing. That doesn't matter until and unless these numbers are positive. Say A1, A2, A3 are positive, A1, A2, A3, A4 are positive. Until and unless they are positive, this S4 will be greater than S3, will be greater than S2, will be greater than S1, because you are adding up positive numbers. But say this is a decreasing AP, say A5 is less than 0, is the first negative term. Then adding A5 will this A4 will reduce its value rather than increasing. So S5 will be less than S4. So these are some important observation. Pretty simple observations. Now solving the problem is as easy as what? As easy as, okay, whatever. So say ABC are in AP. A plus B plus C can be written as what? 3B equals to S. ABC are in AP. This can be written as 3B. How? Just take A plus D and A plus 2D and analyze, you will get this. So when the number of terms are odd, we can take out the middle term and write it in this format. Now what about when the number of terms are even, right? A1, A2, A3, A4. Their addition is equal to what? This is 4 n by 2 into A2 plus A3. Why? How we are considering the AM? Anybody knows? What will be the AM? What does the AM of this A1, A2, A3, A4 lies? The AM will lie between this and this. So AM lies between this and this. Equally inclined, I can say. Equally inclined. So the AM will be what? A2 plus A3 by 2. This will be the AM. Now this is the AM of these also. Of these expressions. Right? So AM multiplied by number of terms gives us the sum. You can take it as a note. Arithmetic mean multiplied by number of terms give us the sum. Take it as a note from me. So AM will be A2 plus A3. Symmetrically add number of terms here and here. The AM still remains unchanged, unaffected. Now my question is that for S16 what will be the AM? For S16 what will be the AM? After that much explanation, it's easy to answer this. For S16 the AM will be 16 into what? This will be the expression of S16. N into the AM, this will be what? 8, right? So S5 can be written as, sorry, S15 can be written as 15 times A8, and S16 can be written as 8 times of A8 plus A9, right? Now this is greater than 0. It is given in the question. Look at this. Means that A8 is greater than 0. This is less than 0. Means that A9 is less than 0. So from here, the first explanation that I have given at the very beginning of the question, that A1, A2, A3, so on, A8, definitely they are decreasing, but their value is greater than 0. But A9 is the first term which is negative. Who will give me the largest ratio? The smallest term divided by the highest sum. Highest sum divided by the smallest term. So highest sum will be shown by what? S8. Because S8 is the sum of the all the positive numbers, right? So S8 will be greater than S7, greater than S6. Because they are adding a positive number, definitely they need to be larger. But S9 will be what? S9, a negative number is added with S9. So S9 will be less than S8. So S8 is the largest sum and 8 is the lowest positive term. So the highest ratio will be given by S8 by 8. If you are having difficulty in understanding the way I have solved the question, just look at this question from the very beginning, the very first explanation, you will get it. I will reveal the sources. Definitely. Why not? This is China. Written only. China 2009. This is also China 2009. Now, an consists of positive numbers for any integer. Find a formula for its general term. Easy, easy, easy. Very easy question. First thing is to get rid of the square root. Yeah. First thing is to make the perfect square. What I have written, everything is managed. So in this way, you will get the expression an plus 4 plus 4 8. Now what we will do? You have solved this type of questions even if you just look at the basic book, which is referred to as the prerequisite, the class 10 book. You'd get this type of questions giving a relationship between an and Sn. So how do you solve this? You will take Sn minus 1, right? Now what should be the next step? Oh, this will be not squared, right? This will be not squared because this was already present in the whole square. That's why I'm thinking that if this is squared, this idea will not be applicable. Yes, 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 right. That should be linear. Right, 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 right. My bad, my bad. So we can subtract this equation from this. What we will get? An square minus an minus 1 whole square plus 4 times of an minus an minus 1 equals to 8 times of this. Sn is what? An plus a n minus 1 plus a n minus 2, so on, a1, right? And what is this? What is this? This is Sn, right? This is Sn. Isn't it Sn minus 1? So what we will get here? Subtracting them, we will get 8an. This is the wonderful part. This is the wonderful part. From here, how do we approach further? A square minus b square formula. I think something will be cancelled here. Yes, 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 yes. If I'm not wrong, this should be the calculation part. Yeah, absolutely correct. So since these are positive integers, we can't write an equals to minus of an minus 1 because the sequence has been defined over positive integers. So we will cancel them. Let us cancel them. We will get an minus of an minus 1 minus 4 equals to 0. That is an equals to an minus 1 plus 4. Now this is what? Recursive form of AP. At the very beginning we have discussed. That's why this was discussed. This is recursive form of AP. Now to define a AP, we need the value of the first term. How do you get the value of first term? Very easy. Use the fact S1 equals to A1. S1 equals to A1. Put here S1 and find out the value of A1. What will be the value of A1? Just find out using this. Okay, let me find out. A1 plus 2, 2 root 2, A1. This is also whole squared. This is also perfect squared. This is 8. This will give us simple formula. A1 plus 2 whole square equals to 8A1. This will be A1 minus 2 whole square equals to 0. A1 equals to 2. We have got the first term. We have got the common difference of the AP. So the general terms formula will be an equals to 2 plus n minus 1 into 4. This will be the general terms formula. Unimaginable, right, that you are solving questions from Chinese Olympiads. Yeah. This was also easy. Find the sum. This is a subjective type question. The proof that you have used for various kind of series like GP. So I'm just giving the hint how to solve and approach this problem. Put it as and another equation, multiply both the sides by r, you will get r square. The first term will be r square plus 2r cube plus 3r to the power 4, so on, n into r to the power n plus 1. Now this is the first equation. This is the first equation. This is the second equation. Subtract them. S minus of rs. What will be the benefit? Look at this. This 2, 3, 4 into r to the power 4. This coefficients will become 1, right? Immediately after subtraction. This will be r. This coefficients r square, r. This r square cancel. So this coefficient 2 will be removed. Now 2, 3 cancel. This coefficient will be removed. You will get something linear. That is the advantage. R plus r square plus r cube, so on. R to the power n plus 1. No, this is wrong if we're doing this. So on. R to the power n plus n into r to the power n plus 1. Now this is a GP. Apply GP's formula. R is the first term. Number of terms are n. Divide this by 1 minus r. We'll get the value of s. So these are some subjective proving type questions. This kind of complicated series may appear. You need to find out the pattern and eliminate. This is easy. A rubber ball is dropped from a 100 feet tall building. Each time it bounces, it rises to 3/4 its previous height. 3/4, that means that the height is in GP. So after its first bound, it rises to 75, and its second, it rises to 3, so on. What is the total distance of water? This is an infinite GP with r less than 1. This is an infinite GP with r less than 1. This is a direct formulas question. Direct formulas question. No need to discuss this question grammar. Now this is a very good question from JEE. What is happening? What is happening? That's why it was happening. Got it, got it, got it. Just a minute, just a minute. I think my device is having some problem. From the JEE 2013, this is a very good question. Excellent question, I'd say. JEE 2013. Excellent question. Even this kind of questions, I didn't remember. But in Olympiads also, this kind of questions are very oftenly seen. A pack contains n cards numbered from 1 to n. Two consecutive numbered cards are removed from the pack, and the sum of the number on the remaining card is 124. If the smaller to the number on the removed card is k, then k minus 20. There are a lot of approach taking k as something very, very. So I'll give you only one approach, that is using a little bit idea of inequality here. Yes, inequality. What kind of inequality? Just look. We have cards. One, 2, 3 up to n, so on. These are the cards. Now I am removing any two cards, consecutive cards, and the resultant I am getting is 1, 2 to 4. What is the minimum and what is the maximum? Say I am picking the card from the very end, what will happen? And when I am picking the card from the beginning, what will happen? Just think about. Not getting it. Okay, fine. Let me write it more properly. 1, 2, 3, 4, so on, n minus 1, n. These are the cards. N is having the largest value in this sequence. Now, the two cards I am removing are these. Two cards I am removing are these. So, this is the remaining sum, right? I have removed the largest number, and in this case, the remaining sum will be the minimum. Since I have removed the largest number, remaining number will be the minimum. Remaining number is minimum. Now, what will happen? What will happen if I would pick up cards from the very starting? These are the minimum numbers I am picking out, and the sum is this. This will be the maximum because these are larger numbers which are left out. I am picking up the minimum numbers. So, can we say? Now, let me again move on to the first case. In this case, when I am picking out the minimum number, what will be the sum? This will be the largest. Now, what will be the value of this sum? Just find out the sequence value. This value, n minus 2, number of term n minus 2 by 2 into 3 plus n minus 1 into d. 3 plus n minus 3 into d, right? Am I wrong? Yes, 6 plus 2a, 6 plus n minus 1, d is here 1 only, by 2. This will be the sum of this part, right? The sum of this part. And this is the case when the sum is maximum. Why maximum? Already explained. Now, when I am removing numbers, these two numbers, what will be the sum? And this is the minimum. So, can't we say that 1, 2 to 4 lies between this and this? This is maximum, this is minimum. Simply solving this equation, right? Simply solving this equation. I'm not solving it. I know the result. Solving is never my part. You will get this inequality. You know how to solve this inequality because basic mathematics was covered, KVPY method was covered. So solving this inequality is not a very difficult thing for you. Now n is a natural number. Lying between them, I guess this equality sign will not be there. And if it's there, I do not know. You need to take 3 different cases and find out whether you can get a possible value of k or not, such that k is an integer, if these are equal. But if this is not equal to sign you are getting, yes, if equal to sign you are getting, then you need to take 3 different cases. What is happening? I do not know. Sometimes some bugs are happening. I guess this is okay. You will get an inequality like this. So n equals to 50. Now the question is that I am not solving it, so I do not know what the exact inequality will look like. If this equality is there, that means that you need to take three cases for n equals to 49, 50 and 51. Put this on the equation and try to find out the value of k. And in these three cases, where you will get the value of k belongs to integers, right? K belongs to integer. That will be the answer. And if there is nothing like this kind of inequality, simple inequality is there, equality is not there, then n equals to 50 obviously. Now I am solving for the case of n equals to 50. If the smaller of the number is removed, then k is number of term is 50. It is very easy. Now remaining sum is also given, k plus 1 plus 1224 equals to n into n plus 1 by 2, sum of first natural numbers. Okay, sum of first natural number. From here you will find out the value of k because n's value is already sorted out. Find out the value of k and then find out 20 minus k, right? I have given you the approach. I can't give you anything more than this. Last two questions. Let X be the set consisting first 2018 terms of the arithmetic progression 1, 6, 11. Y be the set consisting of the first 2018 term of the arithmetic progression. Then the number of element in the set X union Y. Here I will give you an idea that you would get the better clarification in number theory. When number theory will be started, there I do not know, I am not a number theory specific teacher, so I do not know what's there exactly, but as far as I remember, that in Chinese remainder theorem, right, one technique of solving this Chinese remainder theorem is very similar to solve this sum, where we take the idea of co-prime numbers and solve it. Only this much thing I can give you information. Only this much information I have, you would get the better clarification in number theory, but I will tell you the method because I know it. This much knowledge I am having. Let X be the set consisting of the first 2018 terms of the arithmetic progression 1, 6, 18, 11, and Y be the set consisting of the first 2018 of this 9, 16, 23. Then X union Y is X union, right? We need to eliminate the common terms. Okay. Set theory is also not yet covered. Set theory is also not yet covered. Better leave this question for set theory. I will take your set theory classes because set theory is a part of combinatorics. Better leave it for set theory classes. Then we will discuss this question. That would be very good. Leave it for set theory classes. Just give a and leave it for set theory classes. The last question. This is easy only. I have given you the idea. Okay, let me give you the idea. Suppose this, we want to find the X intersection Y. Okay, the common terms of both the AP. How we will find out? That idea I am giving you. If you can find x intersection y, you can easily find out x union y if you know a little bit of set theory. Just look. What is the common difference here? 5, right? And what is the common difference here? 7. Since 5 and 7 are co-prime, the common difference of the arithmetic progression that will get in this x intersection y will be 35. So now what will be the first common term? That is a task, and the easiest way is up to 11 it's not matching, right? Let me write from 11 only. 11, and then it's given common difference 5. 16, 21, 26, 31, and here I am writing from 23 onwards. 7, 30, 37, 31 plus 5. Such a long series. When you will learn Diophantine, this kind of questions will be damn easy for you. Bajot's identity is there. I think, I'm not expert of algebra. I think that this kind of questions can be solved using that methods also. Hey, what's the first common term? Look, 51 is the first common term, right? 51 is the first common term. So this will be the first common term, and the next common term will be of the format 51 plus 35. Now why 35? Because 5 and 7 are co-prime to each other, so the common difference of this two sequence, intersection of these two sequences will be like this. So the general term of their intersection, x intersection y, will be of this format 35 into n. You can find out the number of term in x intersection y. If you can find out the number of term in x intersection y and you know a little bit of set theory, you can easily find out the number of term in x union y. Yeah, sets we will discuss for the sake of combinatorics, because few questions are asked, so you need some basic definition ideas. IOQM 2020, a very easy question. The answer of this question is a mystery till we will solve this. A group of women working together at the same rate can build a wall in 45 hours. When the work started, all women didn't start working together. They joined the work over a period of time, one by one, at equal intervals. Once at work, each one stayed till the work was completed. If the first woman worked for 5 minutes, 5 times as many hours as the last woman, for how many hours did the first woman work? Okay. First thing in this work concept, this question was solved in the very first lecture of ratio and proportion. Not the first one. The first lecture of basic mathematics. This is the beginning of algebra, we can say. Ratio and proportion. This question was solved. This is again an easy question. I do not know why they ask such kind of easy questions. 45%, n person can do a task in 45 hours. One person can do the task in 45 by n hours. Is it? One person is requiring less time. No. One person can do the time tasks in 45 into n hours. So this is one person doing the task in 45 into an hour. Let the task be some t, and let me consider the value of this task as 1. The complete fraction is defined as 1. That's why I'm considering this as 1. So one task done by one person takes 45 n hours, right? So in 1 hours, how much fraction of the task will be completed by one person or one woman? 45 n in 1 hours. This amount of tasks will be completed. Now, the women started the work. All the women didn't start working together. They joined the work after a regular period of time. Means, say the first woman who started from the very beginning worked for T hours. Then the next woman who joined some A hours later. The total time she worked is T minus A. Third woman worked for T minus 2A, and so on. The first woman worked for T hours, the second woman worked for T minus A hours, the third for T minus 2A hours. And the last woman worked 1/5 of the first woman. There is a last woman work for T by 5. Now, isn't it arithmetic progression? Yeah, this is a arithmetic progression. The women joined after a regular interval of time and they worked for this much time. So how much tasks did they completed? The first woman completed T. In 1 hour, how much tasks she is completing? 1 hour 45 n. So in T hours, she will complete T multiplied by this much tasks is completed by the first woman. And the next woman will complete T minus A. This is arithmetic progression, clearly visible. With last term this 45 n. So on till the last woman. Till the last woman. And the total task, which is 1, is completed, right? We can take this 1 over 45 and common. Now what is the sum of a AP? Sum of a AP, I know that this formula is not provided because the junior faculties, they may not give you this all this thing in detail. I do not know whether this is provided or not, but I guess that this is not provided. 2a into n minus 1 into d. Oh, this is very well known formula that should be provided. This is the sum of AP, n by 2. This can be written as what? A plus a into n minus 1 into d, n by 2. This is what? The last term, a plus l, a plus l. So this is also sum of AP. And this is what? Again, n into a plus l by 2. This is what? The arithmetic mean. And this is n. N into arithmetic mean gives us the sum. Just we have applied this in one question. So this is arithmetic progression. Now let us focus on this. This is t. This is t. This is arithmetic progression with n number of terms. Last term this. Apply the formula. A plus L, task completed, that is 1. N and n cancelled over. T equals to 75 hours. This was the total time. So this all these 10 questions were very good questions, and we have completed them. That's it.